In this video, I will discuss how to use the VGG16 pre-trained model to predict class probability for new image. We can start by importing a pre-trained VGG16 model from TensorFlow Keras. And to do this, I can simply do tensorflow.keras.applications.vgg16 and then import the VGG16 model. So I can run this. So this is going to take some time because it actually has to download the entire VGG16 model. Now, if you remember, VGG16 is a very large network with around 138 million parameters, and it accepts images of the dimensions 224 by 224, applies many rounds of max pooling and convolution, so it gradually shrinks the input image from say 224 by 224 to all the way to 14 by 14 and then by 7 by 7, increasing the depth of the number of channels each time. And finally, it predicts the class probability of 1000 classes, and the classes are cat, dog, chair, etc. These are real world images. Now, coming back to our notebook, our model has been downloaded from the internet, and now I can do model.summary to see how the model looks like, how many parameters it has, and so on. Let me make sure that we have the right runtime. We want to make sure that we're using GPU. Okay, we have GPU, that's good. So in model.summary, we can see that the network accepts 224 by 224 image, of course RGB 3 channels, and then gradually it shrinks the input image dimension to 7 by 7 and gradually increasing the number of channels from 3 to 64 to 128 to 256 all the way to 512, and then there are two dense layers at the end followed by the one last dense layer to predict the classes. So it has around 138 million parameters total. Next, we can use the plot model function in Keras to visually inspect how the model looks like. So I can do plot model and then model, and we can see that the first layer is a 224 by 224 by 3 input image, and then we have conv2D layer, and gradually it goes all the way down to the layer where we flatten the inputs, and then we have two dense layers, and the last dense layer has 1000 outputs. Now we can use this pre-trained model that Keras comes with to make predictions for new images. So I have a dog picture that I would like to upload. So I can upload this image here into Colab by choosing this picture. And then this dog.jpg, that file that I have, I will need to resize it to a target size of 224 by 224 because that's the dimensions that the VGG16 can only accept. So I'm going to load this image. Now let's visualize the image to see how the picture looks like. The next step is to convert my input image into a Numpy array so that this Numpy array can be fed into the VGG16 model. So I'm going to run this cell and call this function img2array, so my image becomes a Numpy array now. After that, we'll need to reshape the image so that we have this additional dimension of batches or batch sizes. The next step is to pre-process the input image. What we mean by pre-process is when we trained VGG16 or where somebody trained the VGG16, they may have actually transformed the input images, for example, maybe normalized by dividing by 255 and etc. So we have to apply the same pre-processing into our input image before we can send it to the VGG16 model. So once we do that, then all we have to do is now call model.predict. So now we have y hat, a variable that holds all the predictions in our case. Now if we print y hat.shape, we're going to get at least in one dimension, 1000 values. And the shape shows that we have 1 by 1000, and these 1000 values represent the probability for the 1000 classes on the data set that was used to train VGG16. Now what we would like to do next is print these probability values, and I would like to format them to 3 decimal places, and let's see what these 1000 values look like. So here we go, we have these 1000 values. Most of the probabilities are 0 because the model thinks that it doesn't belong to most of the classes. The highest that we see here is here. I see that for this class the probability is 13.8%, for this class is 13.4%, and for this one it's 2.3%, and so on. Now it's difficult to know what these indices of these vector mean. So say for example at this position, when we have very high probability of 13.8%, what does this mean? So to decode that, Keras comes with this method, decode predictions, that we can import, and all it does is it simply takes the predictions and decodes it to labels that we can understand. So let's run this to extract the label with the highest probability. And in this case, the highest probability label is Pembroke, which is a type of dog, and in this case, I think the model made a reasonably good prediction. So overall, this is how we can use pre-trained models such as VGG16 to make predictions for images or image data sets of our own choice. We can simply load the model. Now the limitation is that the model will be only able to predict the classes that the model was trained on.